And before I get started, please actually imagine a scenario. Imagine that tomorrow there will be no electricity. For sure, that's not gonna cause much of an issue. It will be an issue for sure. But let's also imagine another scenario that there will be no internet. Okay, that is going to cause us into a bit of a chaos because everything right now all relies on the internet. But if I tell you that there will be no water tomorrow, that will cause us into a catastrophe. And if we extend it quite long enough, we might end up even erasing our existence on Earth. Although these scenarios might seem a bit far-fetched, this might end up being our reality if we cannot find a way to sustain ourselves. With the current issues with global warming and the effects of climate change, we are actually losing a lot of resources. We're running out of them. And particularly, we're running out of water. So government agencies and researchers do try their best to come up with solutions to combat this issue by providing a better water reservoir system, providing a better water treatment technology, and so as desalination. So for my topics today, I'll be talking about desalination process. Particularly, I'll be talking about the compatibility of three desalination process in California, which includes multiple effects distillation, MED, reverse osmosis, RO, and a hybrid of multiple effects distillation, reverse osmosis, MED, RO. For the overview of my presentation, I'll be going through the definitions of the terms that I mentioned before, along with the methods that I have used for my presentation, and the factors that I include in my comparison, which includes economics, environment, regulation, and also I'll be discussing about the interpretations of the data that I have found. So, before we start anything, what is desalination to begin with? Desalination is known as a process of removal of salt or other impurity from seawater to produce fresh water. Desalination is divided into two types, non-thermal and thermal desalination. In this sense, thermal means using heat and non-thermal means doesn't use heat. And a perfect example of thermal desalination would be multiple effects distillation. Multiple effects distillation, just like in its name, utilizes the process known as distillation. Distillation is a process where you take impure water, boil it down so that it can produce a steam that can be then condensed to form water. And in this case, as you can see in this diagram, the MED process utilizes the heat by going through this evaporated tube. And in the MED process, it is divided into three compartments, and these compartments are known as stages. And you might think, okay, those stages all look kind of similar to one another, but it's not. The main difference lies on the main difference of the first and the other two stages lies on the energy source. For the first stage, the main energy source would be the external source that could be used. An external source in this could be a fossil fuel type of source, it could be solar panel, it could be any type of energy source. But it is an external one to heat up the evaporating tube. For the second and the third stage, however, utilizes the steam that is produced from the first stage to heat up the evaporating tube. You might see that this system is quite efficient. However, at the first stage, it still requires a lot of energy, so it's making the multiple effects distillation quite an energy-intensive process. So, another type of desalination plant that doesn't use a lot of energy would be reverse osmosis. So, what is reverse osmosis? Reverse osmosis is a type of desalination process that utilizes a membrane. In this case, it's a semi-permeable membrane, which acts almost like a sieve, a filter, which filters the salt and other impurity from seawater to produce fresh water. The way that it can be done is by using an applied pressure to force out the fresh water and extracting all the other impurities. So, now that we understand those, now we can look at the hybrid version of those two. A hybrid MED and RO hasn't really much been studied on, and there's not really an exact way to kind of define it. So in my case of study, I decided to define and the desalination compartment. The energy compartment in this case is just acts as an energy source to provide for the MED desalination part and also the RO part. You might ask again, how is this different from the other two that I just mentioned a moment ago? Well, the main difference, the main trademarks, the main properties that make this special is that the waste or the brine from the RO will be actually collected back and sent back with deep water and added back into the energy process so that it can be distillated once again. You can see that this proposed technique actually could act as a more efficient way to produce this, to utilize this desalination in general. So now that we understand the definition of it, we also have to understand the scope of location that we have to look up for desalination. In my case, I decided to do a study case on California because the reason why I decided to pick California is due to the susceptibility of California to drought. And in case to really showcase that would be the drought that occurred at the end of 2012 till 2016. And we still have limitations on our technology to really predict drought. So finding an alternative way to support ourselves would be great, and desalination is one of them. So for the method of my review, I decided to read a lot of collect a lot of journal articles and study a lot of data from them. And also I have collected a few government data by utilize them to formulate my thesis and conclusion. And I also studied a few government policy regarding desalination. So one of the first category that I'll be talking about in my comparison is economics. Economics is quite broad. So for my case, I decided to narrow down my studies based on levelized cost of water. So what is levelized cost of water? Levelized cost of water is the measurement cost of efficiency of a certain infrastructure. And in this case, the infrastructure is a water infrastructure. As you can see in this table, amongst all of those three processes, RO ranks as the lowest cost compared to the others. And here's my clarification for the result of the bottom one. California desalination in this case, I read the academic paper, but there's not really much information provided on which specific type of desalination plant that is used. But in comparison to the California desalination, you can see that RO is still kind of a way cheaper compared to the other process. Another factor that I have included in my presentation is environmental. When talking about desalination, we also have to think about the environmental impact of it. And among the environmental, I have separated into two parts, which is the brine concentration and the recovery rate, and also the energy consumption of desalination plants. In this table, as you can see, the brine concentration and the recovery rate has a direct correlation between those two. The higher the brine concentration, the higher the recovery rate. But first, let me backtrack you. You might be disaster on me right now. What is brine concentration, you might ask? And what is recovery rate? Well, brine concentration is the amount of salted solution produced after fresh water being extracted from seawater. Actual recovery rate refers to the rate of fresh water being produced. Once again, you can see that there's a direct correlation between the brine concentration and the recovery rate. And the reasoning behind this, why RO has such a high recovery rate and also a high concentration, is because there is more fresh water being pushed out and being produced in the RO system, which leading the concentration of the salt being higher in for RO, which is why the reason why it is high in the gas. And another part fact that I considered in environmental is the energy consumption. In my case, the energy consumption, I will define it as the energy to produce 1 centimeter cube of water. And once again, we can see that the energy consumption in RO is much less than compared to the other two. And the reason behind it, like I mentioned before in my defining, is a very energy-intensive process, which means that it requires a lot of energy compared to the RO, which only needs energy to produce high pressure to push out the water. And last but not least, we have to look at the regulation. Regulation is important when we talk about desalination because it's such a controversial topic. In California, particularly, there is quite a strict regulations upon desalination plants. According to the National Pollutant Discharge Elimination System, they require permit in order to actually dump solutions or any type of brine or anything like that into the water body. And these permits allows them to monitor the brine effluent and cleansing testing that is provided by the U.S. Environmental Protection Agency. Another factor that I have looked upon is that California is actually pretty progressive when it comes to this desalination project. They actually published a paper basing on the siting and streamlining of desalination plan by trying to expedite the process. And in that paper, they focus on how to reduce the environmental impact and also reducing the human factors, cutting down the controversy about desalination plants. So, for my conclusion and discussion of this presentation, based on the presented information that I have shown, what I have reverse osmosis is theoretically would be the most compatible and feasible process in California. However, most of the data that I have presented are mostly estimation, and the data have been taken out from academic papers that have conducted in several different places, which could also impose as a bias. Moreover, there's not really much government data that has been provided in regarding this topic, and there's not many research papers that have done on the hybrid of NED and RO. So, what can we take away from this whole project then? Well, from my understanding, I believe that although desalination is still one of the most controversial topics, I still believe that it still holds value for us to kind of study so that we can actually reduce the environmental impact and also the human and also kind of trying to cutting the cost down so that it could be more accessible to other countries too. Water will right now our population is still will keep on growing, and that might impose will impose some issues on our resources. And I feel like by studying it, we can improve desalination and maybe we can expand it further.